right, gang, it is lab number 10. Double digits, baby. Let's get right into it. Last time around, we were talking about the appendicular skeleton. Well, today, it is sexy time because we're going below the waist. Let's start off with the biggest bone that you have in your body, the mighty femur. Now, you'll notice there is a single bone in the upper leg, just like there's a single bone in the upper arm. So this is a homologue, a mirror of the upper limbs, but now we're talking about carrying your body weight, so these guys have to be thicker. The femur is very distinctive. If you take a look at the morphology, the proximal aspect of the femur is very different from the distal aspect. It has that round kind of morphology, and we saw that in the humerus, the head of the femur, followed by the neck of the femur, the head and the neck. And then you've got that long shaft, and the distal aspect, we've got the condyle, just like we saw with the humerus, a condyle. Be sure you're tight on all of these names because you might see that on your quiz later today. Here is the femur in action, carrying your body weight. As you lift one leg up, you've only got 1 foot on the ground at a time. Here is the head of the femur, the condyle of the femur making up the knee joint. Now, the problem with being a biped is you wobble if you don't have your legs positioned properly. What's up with having legs that are straight? Well, this is fine when your legs are planted on the ground, when both feet are on the ground. But when you walk, you lift one leg up. And so now, if the center of gravity is in the midline of your body, having a leg that's straight is going to lead you to tip over. Well, humans have devised an ingenious strategy so we don't tip over when we walk. We have angled our knee joint. And by angling the knee joint, the center of mass is now still above where the foot is planted on the ground. And so gravity doesn't pull us over. Humans have this double angle. Each leg is angled towards the midline, so our feet are planted firmly beneath the center of mass. And this knee angle is therefore diagnostic of bipedality. Keep an eye out for that. When we start looking at fossils, we're going to know they're bipeds because they have this knee angle that the apes do not have, a dog doesn't have. Humans have this knee angle which keeps us from tipping over. Compare that to something like a gorilla or chimpanzee. Marching on. The femur is wrapped in muscles. On the front, you've got your quadriceps, you've got some other muscles. You really can't feel the femur. On the back, on the right side of this image, you've got a whole bunch of things like your hamstrings, and this leads to several markings on the bone. In fact, the quadriceps on the front of your leg actually wrap around to the back and leave behind a huge ridge. On the dorsal aspect of the femur, the back of your femur, you've got this raised line where a whole bunch of very powerful muscles latch on and dig in. That has a special name, and I'm going to want you to know this. It's called the linea aspera. Linea, line, aspera, raised, like you aspire to raise yourself up. The linea aspera is also diagnostic of bipedality. We don't see this on dogs or cats or chimps or gorillas. So when we find fossils, sometimes we just find a shaft. If we find the linea aspera, we know we've got a biped. We're moving down to the lower leg, and this is your shin bone, more properly called the tibia. Everybody say tibia. Now it's got a partner, just like your arm bones up in the forearm. Here, you've got the tibia, which is the main weight-bearing bone, and a little sidekick called the fibula. Everybody say fibula. Excellent. Excellent. Check it out. The tibia, the fibula, working as a team. The fibula is lateral. Notice that the tibia, the big boy, is more medial. How are you going to remember this? Pretty simple. The condyle of the tibia is flat. And if you look at the shaft of the tibia, it kind of makes this perpendicular pattern that looks like the letter T. What is the name of that bone? Tibia. T for tibia. Oh, T is also for thick. It's a big fatty fat bone. Carries your body weight. Well, this little guy, the fibula, is always lateral, and it tells you that because the last 2 letters stand for lateral. The fibula. It's lateral. The tarsal bones. bones are counterparts to your carpal bones. You've got a whole bunch of these guys. They're bigger and fatter because they bear some body weight. Of course, the lower limb is going to be more massive. It's going to have more density. You get the idea. Okay. One of the last bones we're going to look at. What do we call this? Don't call it the pelvis. Don't call it the pelvis. We call this the innominate. The innominate bones are on the lateral aspect of the pelvis. Why don't we call these the pelvis? Because there's this guy sitting in the middle. Interposed between the two innominates is the sacrum. Now that's not part of the appendicular skeleton. We're going to meet that guy next lab when we talk about the axial skeleton. Today we're talking about those lateral aspects, the innominates. Innominate, by the way, means no name because it didn't look like anything to anatomists, so they couldn't come up with a name. They just called it the innominate. This bone is actually made up of 3 separate bones that fuse when you're 13 years of age: the ilium, the ischium, and the pubis. And you can see here these 3 different colors represent 3 separate bones when you're a kid. But at age 13, they fuse together right in that circular structure called the acetabulum. The ilium, the ischium, and the pubis. This acetabulum is the hip joint. This is where the head of the femur sits. And you can see they make a beautiful articulation, this ball and socket joint. The appendicular skeleton. Make sure you know all of your bones. Now we've got the lower bones, the femur, the tibia, the fibula, the tarsals, and the innominates. Play some Simon Says, practice your bones, and I'll smell you next time.